placeholders are 1, 2, 4, 8, 16, 32, 64, 128. Add all those together because they're all turned on, and you get a decimal value of 255. Same thing for the fourth octet. Alright, so let's obey our rules that we printed earlier. A 0 must match. So bring everything with a 0 in the mask down. And the same thing here. These are all zeros. Dot. There are no zeros after this, so we don't need to bring anything down. Only the masked zeros do we bring down. So this is our access list command. This is the IP address that we're trying to get across that access list as a source address. Let's look at it. 192.168.1.1. The binary equivalent I've written out. This is 192 as it was up here. This is 168 as it was up here. Now it's a bit different. This is 1 and this represents 1. Now our mask is exactly the same. We're still using the 0.0.255.255 and you see that here. So let's match the zeros. 1, 1, 0, 0, 0, 0, 0, 0. Because all we're doing with these zeros is bringing down exactly what we see in that IP address. 10, 10, 10, 0, 0, dot. These are all ones, so we don't have to worry about it. Once the computer has done this, you ask one question, one simple question. Do we have a match? Is this value right here equivalent to this value? Yes, it is. And because it is, we follow through with whatever action is in this line. That's too cool, isn't it? I mean, that's as simple as it gets. This is the long form of what the computer is doing. You know, I love that when you actually know what's going on behind the scenes. All right, that's pretty straightforward. We're going to try another example now. Our next example is going to be a bit more tricky. All the concepts are exactly the same though, so stick with me. All right, you see our command again. Access dash list 99 permit 192.168.17.65. So above, so far with this IP address is exactly what we saw in the last example. And we'll see that here. The 192 binary representation, 168.17.65. This is where it gets different, is our mask. This time it's 0.0.16.64. So let's look at that. 0 is all zeros. Again, the 16, only the 16th digit is active. So again with our placeholders, 1, 2, 4, 8, 16, it's on. 32, 64, 128. This is a value of 16, and this is the value of 64. So let's obey our rules and bring down everything that is a mask of 0 from the IP address. So 1, 1, 1, 2, 3, 4, 5, 6, 1, 0, 1, 0, 1, 0, 0, 0, dot 0, 0, 0. We're not going to bring this down, and the reason for that, I'm just going to leave it blank, is there's a 1 there. 0, 0, 0, 1. You saw we brought that down from the IP address. Dot 0. This is blank because it's a 1. 0, 0, 0, 0, 0, 1. Finish that 0 there. Alright, we do the same thing down here. The same IP address we tried to pass earlier, we're trying now. 192.168.1.1. Binary representation 192.168.1.1. The mask, exactly what we saw up here in the mask, we have down here. So let's work this out. For the zeros again, we bring it down. 1, 1, 2, 3, 1, 0, 1, 0, 1, 0, 0, 0, 0, 0, 0. Ignore this place. 0, 0, 0, 1, dot 0. Ignore this placeholder. 0, 0, 0, 0, 0, 1. Alright, then the computer simply asks itself again, does this number match this number? And they match exactly, and we pass the traffic, because in this case we are allowing a permit. See how crazy that mask is? And it's not as easy as zeros and 255s only. We have these bits in the middle of our octet being ignored. And that's why the key was on the first slide. All 32 bits in an IP address can be turned on or off, ignored, or paid attention to based on this mask. You can get into some wild configurations. Just take care that you don't do that often, because it's an administrative nightmare if you do. So use your access list wisely. In some cases, you might have to do something like this. And if you do, administer that access list on your own, because as soon as somebody else comes in and takes a look at it, there's a great chance that they're going to get confused and make a mistake. All right, let's go on to our next topic. We just got through covering ACL filtering, probably the most important part in this section of the ACL Essentials. Next, we're going to go into ACL processing. All right. The big question here is this. In reading an ACL, there's two choices. Well, with any list that you're ever going to run into in computers, it's either processed by first hit or best fit. Now, in the case of an access list, it's first hit. This is the answer, and we're going to illustrate how that happens and why it's important. Here we go. I have three different access lists here, 1, 2, and 3. We're going to pay attention just to the first one for our first example. Here we go. Access-list 99. This time we're going to deny. So understand we're denying a host. Remember our key words and looking at this command and the filtering. If you have a host, it's really the equivalent of writing out 192.168.1.1 as an IP address, and then the mask 0.0.0.0. They save you a little bit of writing by allowing you to put down the keyword host. And it just makes more sense too as you're reading these access lists. The next line, access-list 99 permit anybody, which again is a shortcut for 255.255.255.255.